Mod 13 study guide. Here we go. So number 1, name the side opposite of Q. So basically, here's our reference angle, Q. Okay. Opposite again is literally he's looking all the way across, and it looks like they call this guy RS. Okay, side R to S. So number 2, name the side adjacent to angle Q. So we're still working out of angle Q, and we already found our opposite side. Now the adjacent. Now remember, if you're not sure which one the adjacent is, find your hypotenuse first. Your hypotenuse is always across from the 90-degree angle, always. So therefore, your adjacent is usually your next door neighbor, which is called QS. Okay. All right, number 3, what is the tangent of D? So we're going out of a reference angle of angle D. Remember, there's something you need to remember for your test. So, toya. All right. So we're looking for tangent. So we're looking for OA. Okay. That means opposite over the adjacent. So the opposite is 13 over the adjacent, which is 9. Okay, if you're allowed to leave it as fraction form, you can leave it like that in your test. If you want to use the approximation, just double check and see if I asked you to round to the nearest hundredth or tenth. Just double check, make sure you're okay. All right, now sine of angle D. Let me use a different color. We'll go green here. Sine again is O. Okay, so opposite, which we already said is 13. Okay, over the hypotenuse, and remember the hypotenuse is always going to be across from the 90 degree. Okay, so opposite over the hypotenuse. Again, you can leave your answer like that, that's fine. Just remember which one's which. All right, let's use a different color. All right, cosine of angle D. So we're still operating within that reference angle of D. Cosine, though, is ka, all right, or ah. So adjacent over the hypotenuse. Okay. So you have 9, the adjacent, over the hypotenuse, 15.8. And you're good. So remember this. You need to remember that. That is 80% of trig right there. All right, number 6. We're going to find the length of GI. Awesome. I'll use red because it pops out like firecrackers. And we get a reference angle for angle H, okay, 68 degrees. And they actually give us a side length. Now, when they give us this degree for angle H, that's our reference angle. So we want to find GI. I'll call him X, all right? So we're going to find X, or GI, okay? X is what to our reference angle? Is he the opposite? Is he the adjacent or the hypotenuse? He's the opposite. Okay? He's the opposite. Now, we do have something given to us. What kind of side is he? Is he the hypotenuse? No, he is the adjacent. Okay? Now we have an O, we have an A. Toya. We're doing tangent. Tangent of what? Well, what is our degree for our reference angle? 68 degrees. Okay? And that equals the opposite, which is X, or GI, over 4. Okay, how do you get rid of a dividing 4? Because we want GI or X all by himself. Multiply both the left-hand side and right-hand side by 4. So you're going to have X equals 4 tangent of 68 degrees. In your calculator, and practice this, do this right now. Make sure you are in degrees. Okay, DEG should be on your screen. If not, ask your teacher to see how to put it in degrees, because if you're not in degrees, you could have your entire test wrong, and that would suck. Okay, so make sure you're in degrees. All right, 68. Type 68 in. Press tangent. you should get 2.4750, blah, 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 blah. Okay. Multiply by the 4. Okay. And you should get, for GI, or in this case I called it X, okay, 9.900, and if that happens, just yeah, that's fine. So there you go. And double check. Don't do the rookie mistake. We're talking about centimeters here. 9.9 centimeters, not 9.9 giraffes. The giraffe is probably missing his tail. Okay. Now, number 7, are sine and cosine reciprocals of each other? Explain. Reciprocals. So let's think about this. If I have an example of a triangle, a right triangle, okay? Let's say the height is 2, 3, 4, and these are just abstract numbers. I mean, it probably doesn't even work, all right, because of Pythagorean. But let's say it was, all right? You have this reference angle, okay? We'll call him angle A. This angle is reference B, C, and basically you say, well, sine of angle A equals the opposite over hypotenuse, which is 3 over 4. Okay. Now, when they say reciprocal, they mean basically this, and it just goes 1 over 3/4, which is really just 4 over 3. So to see if this is actually a reciprocal for cosine, you will actually do this for cosine. You'll say cosine of A equals adjacent, which is 2, over 4, which is reducible as 1/2. Now, 4 over 3 does not equal 1/2. Therefore, they are not reciprocals, okay? They are complementary, okay, and that's probably what you would have to say, okay? They're not reciprocals of one another, but they are complementary to one another, okay? So, for example, in number 8, and there's a question like this on your test, okay? Given that cosine of 42 degrees equals, or approximately 0.743, what is the sine of the complementary angle? Complementary angle, remember, means it adds up to 90 degrees. So, what you take is cosine of 42 degrees, okay, really just equals the sine of 90 degrees minus, and let me use some, there we go. That's better. Of the 42 degrees, and you're going to get sine of, try it, 90 minus 42, and you should get 48 degrees. Okay? Now, if you type that in the calculator, if you get 48, press sine, and an interesting thing occurs. Your ratio is also going to come out to be 0.743. That's how if you know you're doing it right. If it's not going to be identical with the ratio, something's wrong, okay? Something's very wrong, so double check your work over in this area, okay? So again, it's probably going to be a 2-part question. Make sure you just show all your work, okay? Something like this, you definitely want to make sure you show all that work, okay? And again, this is a great way to double check, and it's also, I think, a second part of your answer, okay? So again, complementary, they both add up to 90, so you just find the missing piece and then press the other ratio. All right, so number 9, what is LK? Round to the nearest hundredth. Show all your work. So LK, let's say like a building, right? Okay, hopefully we did that. You have a height of a building. Well, we have an angle, okay? Now, what is the height of the building, or LK, in perspective to our acute angle that's given to us? That's the opposite, isn't it? So let me erase the H, because that's representing height, not hypotenuse, okay? So let's be careful there. This is the opposite side, okay? The hypotenuse, again, is across from the 90 degree. So if we have opposite and a hypotenuse, yeah, we're doing sine. So sine of 35 degrees equals LK all over 9.5 centimeters, okay? We can't have a dividing 9.5, so I'll multiply both sides by 9.5. LK will equal 9.5 times sine of 35 degrees. In your calculator, press 35, sine, you'll get 0.57 something 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 multiplied by 9.5. And for LK, you should get approximately 5.448. They say round to the nearest hundredth, so I'll round up to 4.55. 5.45. 5.45. Ooh, say that 10 times fast. Quietly. All right, and this is meters. Okay, so that's how the cookie crumbles. Number 10. What is JK? And guys, I am not JKing. Okay, there are several ways we can do this. All right, you can use your answer from number 9 to use Pythagorean theorem to find the missing piece. That can work. If you really want to test yourself. This is the adjacent, okay, and we can still use the hypotenuse. So we can actually use cosine if you want, okay, for this. Cosine of 35 degrees equals JK, and we're not JKing, over the hypotenuse, which is 9.5, okay. If we do this, it's going to be just the same process as number 9, except instead of using sine, we're using cosine. So in your calculator, you're going to do the same thing, except instead of pressing sine, we're going to press cosine. So 35 degrees cosine. You're going to get 0.819 something 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 multiplied by 9.5. And you should approximately get 7.781, round to the nearest hundredth, it says. And remember, we're dealing with meters, so that works just fine. All right, number 11. What is angle M? So for angle M, we're looking for the angle, okay? We're going to have to use the inverse function of some trig, okay, some trig ratio. Well, we have his opposite, 5, right? We have the hypotenuse, right, the 23, which is across the opposite way of the 90, okay? So we have an opposite, we have a hypotenuse, so we'll use the inverse of sine, okay? So the inverse of sine of the opposite over the hypotenuse, okay? Again, remember, originally you had sine of angle M equal 5 over 23, and now I'm just applying the inverse sine. That's what's happening, okay? So in your calculator, 5 divided by 23, 0.21739, right? Now you're going to press second sine, and then out comes 12.55, okay? Doesn't say to round or anything, so I'll just be as accurate as possible. All right, and that's a degree. And again, make sure you are in degrees in your calculator. Now, what is angle O? Fun fact, you can find this without even using trig. You just know complementary angles. You know that angle O and angle M should add up to 90 degrees. Well, if you already have angle M, just subtract whatever we got from 90. So 90 minus the 12.55, and there you go. You just found angle O. Oh my. Which is 77.45 degrees. Okay. You could also use trig, and you could use the a different reference angle. I think this would be adjacent over hypotenuse, so you would use inverse of cosine, but you should get the same answer. All right, so I'm going to burn through this as fast as I can because time is running short. Those little box things, yeah, that's triangle. Okay, that's a triangle. What are the missing side lengths in PQR? This is a 45, 45, 90, special right, okay? So we know that our hypotenuse has to be x times the square root of 2, and this guy's just x, and this guy's just x. Well, we got the hypotenuse given to us, so we'll set up our ratio equaling to what they gave us for the hypotenuse, and we'll solve for x. So I'm going to divide by the square root of 2. We can't have that square root of 2, so I'm going to multiply everything by square root of 2 over 2, or square root of 2 over square root of 2, which is just technically 1. And then you're going to get, for x, you're going to get 24 square root of 2 all over 2, which becomes 12 square root of 2, which is actually what this guy's side is, right? And fun fact, if you found that guy, this guy just comes with them because they're both the same. Okay, they're both, their ratios are the same. All right, so we found our two lengths, just because special right. All right, triangle TSU, triangle TSU. All right, what are the missing side lengths of TSU? Explain this is a 30, 60, 90. Again, basically, we know that the hypotenuse has to be 2 times whatever this smaller leg is, which apparently they gave it to us, so we already know what x is, because x is going to give it to you. And then basically you have x square root of 3. All right, let's go ahead and plug it in. So if we do this, what's 2 times 8, right? 2 times 8 square root of 3, and that's just going to be 16 square root of 3. Nice. So we got the hypotenuse. Let's go ahead and substitute in here 8 square root of 3 being multiplied by the square root of 3, which is really just 8 times 3, right? Which is 24. So we just found our 2 missing pieces. All right, find the missing side lengths of the triangle ABC using trigonometric ratios. Again, this is a 45, 45, 90. We have these ratios. Okay, they gave us one of our sides. So we have x square root of 2 equals 10. We will divide by the square root of 2. You can't have a radical in the denominator, so we're going to multiply everything by square root of 2, numerator and denominator. You should get, for x, you should get 10 square root of 2 all over 2, which will give you your sides here. 10 divided by 2 is 5, and the square root of 2. And since that guy is 5 square root of 2, then you know that AC is also 5 square root of 2. 45 45s. All right, number 16, what is the area of this triangle? So remember your area formulas. You have area equals 1/2 of one of your sides, which is 4.1, times 7.2. That's a terrible 7. Oh my goodness. It's an ugly 7. Times sine of 42 degrees. Okay, so in your calculator, 42 sine 0.669 something something, right? Times 7.2 times 4.1. Make sure you're pressing equal after you multiply. And then divide by 2, which is technically multiplying by 1/2. For my area, I have approximately 9.876. They want us to round to the nearest tenth. Remember, this is meters squared, so let's round to the nearest tenth, 9.9 square meters. Okay, so remember that formula and how to use it. All right, number 17, show the triangle by finding the lengths of all the sides and the measures of the angles. Show your reasoning. Tell you what, this one I'm going to let you do it. All right, use a reference angle. Okay, this guy is the adjacent. This guy is the hypotenuse. So use cosine perhaps. You'll find the degree. Okay, And then with that, so let's see, cosine of E is 12 over 16.24. Okay. Use the inverse. Okay, so the inverse of 12 over 16.24. So in your calculator, 12 divided by 16.24 equals, and then second, cosine. And I got angle E. Angle E is going to be 42.36 degrees. Be careful about rounding unless they ask you to round. Complementary angles. So what's 90 minus 42.3? 90 minus 42.36. So angle F is this degrees. And to find the lengths, okay, right here, you can use Pythagorean. Okay, you can use Pythagorean. So I want you to practice that. I want you to use Pythagorean and find me df. If you aren't sure on how to get it, raise your hand. Okay, I'll drop by. Number 18. Find the missing side lengths of the triangles using DEF using trigonometric ratios. Well, this is a 30, 60, 90, so yeah, it's not that bad. So I'll tell you what. We already know that this guy is 2 times whatever our leg is, and you solve for x, and you find out this guy's 4. Since that guy's 4, you know that this guy, right, is just 4 times cube root of 3. All right, if you have any questions, feel free to ask. I'm going to set up HRW. Good luck.